This is video one for the linear motion unit notes. So for this one, the learning goals I want you to be able to master, I want you to be able to discuss how Aristotle's motion, or model for motion, shaped history. I want you to be able to explain the difference between Aristotle's and Galileo's models for motion, explain what acceleration is, and make calculations of velocity and distance for falling objects. Now, for Greek scientists or Greek philosophers, we have to understand that they felt that all knowledge was within the human body. So, for them, they never conducted experiments. They simply thought. They created ideas. So, because of that, more than 2,000 years ago, they were familiar with a lot of the ideas that we study today in physics. And they even had some very good understanding of light. However, motion, they were off on. The first to really consider motion seriously was Aristotle. And he divided motion into two main classes, natural motion and violent motion. So natural motion then was thought to proceed from nature, or the nature of an object. So everything in, every object in the universe had a proper place. Its nature. And if an object was not in its proper place, it would strive to try to return to its proper place. So an example of that would be anything made of the earth would try to return to the earth. So that's why objects fell. If something is made of clay, it falls because it's made of earth and it's trying to return to the earth. Smoke would rise because it's made of the earth, made of the air. Keep in mind they did not have microscopes, so they had no idea smoke was actually made of small particulate matter. Had they known about that, that would have completely, uh, you know, destroyed his theory. This next one takes some mental gymnastics. A feather. We all know that a feather will fall as it's dropped. However, it doesn't fall as fast as maybe clay. So, Aristotle reasoned that a feather is of the earth, so it falls. But it's also made of air. Again, that takes some mental gymnastics to kind of think about. Larger objects will strive harder. So Aristotle believed that the bigger the object, the faster it would fall, because it's striving harder. It's trying to get to where it belongs quicker. So he thought that all objects fall at speeds proportional to their weights. And that kind of makes sense in a certain way. If you had a bowling ball and a tennis ball, And if both of them were starting at the same height, which one would you rather hit your toe? Obviously, the bowling ball would hurt a lot more than the tennis ball. So, because it produced a larger force when it hit the ground, he thought that meant it was traveling faster. We know differently now. So, the natural motion itself uh, had three different types. It could either be straight up, it could be down, or it can be in a circle. Those were the three types of natural motion, no left or right. Now, circular motion was seen to be without beginning or end. So, kind of like the stars going around the earth, or the sun going around the earth. Aristotle then believed that different rules applied to the heavens, and he asserted that celestial bodies were perfect spheres made out of an unchanging substance, which he called ether. So, that's something that early religions could really grab a hold of, the fact of perfection. Violent motion. This resulted from pushing or pulling forces. So someone pushing a cart or lifting a heavy weight imposed motion. So if you were to throw something, you were imposing motion. So another example, the wind. The wind would impose motion on ships. Floodwaters. Violent motion is what we would think of as a force today, pushing or pulling. And the essential thing was that it was externally caused and imparted onto the object. So an object could not move, of itself. There has to be a push or a pull. And this is something that is not true, and it's actually something that a lot of younger students still, have confusions with today. For example, um, this concept of violent motion, it had some difficulties. So think about it this way: if you're shooting an arrow, while the arrow is in contact with the string, there's clearly a force pushing the arrow. But what about after the arrow left the bow, as it's sailing through the air? So here's the problem. If something's moving, there must be a force pushing it. That's what Aristotle believed and taught. But as the arrow is flying through the air, there doesn't seem to be anything pushing it. So here's how Aristotle explained it. And keep in mind, this is wrong. So Aristotle reasoned, and remember he was a philosopher, he didn't conduct experiments, he only thought about things. He reasoned that as the arrow moves through the air, it splits the air. And then at the rear of the air rushes back in to prevent the vacuum, and that kind of pushes the arrow forward. Now this is clearly wrong. We can clearly see that this is wrong. But that's how Aristotle had to explain it, because once the arrow leaves the bow, there's no longer any force pushing it. So for Aristotle, he had to come up with something to reason through this. Now, I don't want you to get this idea that Aristotle was, some idiot. He was very, very bright. The problem was, this was pre-science. Aristotle's statements about motion were a beginning for scientific thought. Now, Aristotle himself did not consider his statements to be the final word on the subject. In many ways he was a teacher. He knew that others would come after him and develop his ideas. However, that's not quite what happened. His followers for nearly 2,000 years regarded his views as beyond question, as infallible. And then the church, took on this idea, especially since, the earth must be in its proper place. And since we can't think of a force capable of moving the earth, it seems quite clear that the earth is stationary and that everything goes around the earth. And this is it makes sense if you just sit around and think and, never conduct any kind of experiments. But, obviously this idea is wrong. So, to figure out how to get the correct idea, we'll save that for the next video.